Hello everyone, it's February 11th. Alright, so today flew by very fast. As I was talking about, I just realized I forgot to record some of the stuff I did today about about handling some sensory issues. But anyway, so I coded some jQuery today. Some the HTML, CSS, and JavaScript using jQuery, and I did this in the past. A couple of years ago when I was taking a class trying to code the website. Back then, using all this tool, and not the best tool as I think, but it was decent enough for a small web app, and I haven't touched it for a long time. And now coming back at it, it was interesting, especially you have all the knowledge in React. Well, I never really coded in React directly, but I was pretty decent in React Native, so the two is quite kind of similar. So it's comparisons. I make comparison between the experience. I would say the framework in all the React, I guess Angular, Vue, all of those, they're pretty much similar, and they did solve a very very important problem. It make a programming web app much easier. At least it's the whole thing is more organized in a way. Maybe just I don't know how to really use JavaScript with HTML well, but the way that I was coding is just everything is clammed into one file, and just feel hard to modularize. Yeah, maybe it's just I didn't really know how to do it. Maybe if I know how to do it, it will be easier. Anyway, so today, as usual, we have a hard problem with word ladder. I'm pretty sure this is something I've done before. Yeah, the dog hot. Yeah, I remember this. This is not only I've done this before. It was also an interview question. I think back then it was an interview question I had. Is that Amazon, or maybe it's Microsoft? It could be one of the two. I'm not 100% sure. And I think it's building a graph. We use all right. Let's just take a look. I can't remember exactly, but I think it's building a graph. A transformation sequence from would begin to end using a dictionary is a sequence of would. Every adjacent pair differs by a single letter. Okay. Differs by a single letter. SI for 1 to K is in word list. Note that begin word does not need to be in word list. SK is equal to, and given two words, begin, and in a dictionary, word list return the number of words in the shortest transformation sequence from begin to end, or 0 if no such sequence exists. So yeah, it's just to build. We're going to build a graph out of this, and after build a graph, we simply find the shortest path from this to this, and then we can do, and however we want to do it. BFS, right? We can use BFS for that. So the problem how to build the graph in a very efficient way. So the begin would have 10, and we have 5,000 words. So we just need to figure out if the twos differ by 1. How do we handle this? Differ by 1. Well, differ by 1. and we have everything. We have 10 letters, right? And most 10 letters, and length equals to this. What's the fast way to check if the 2 is different by 1? I seem to know. And I can't remember. Differ by 1. Huh. How do we find differ by 1? Oh, wait, it's a differ by 1. It doesn't, the order doesn't matter, right? No, I think it's the word differ by 1. So it's actually one position is different. Okay, one position is different. I mean, one way that I remember is we can just take it away so that we have remaining, right? And so for every word, I can just take one away. And after I take one away, I just organize them together. They will differ by 1, right? So for each word, I'll take this away, take this away, and take this away. And every time I take it away, I created a new string, and that could be that could be the signature, right? That could be the signature, and we can use that signature to group all the words. Like if I remove this, it becomes H and T. I remove this, it's become H and T. So these two can link. So after this step, we will find the groups, right? We'll find the groups of words that can link to each other. That can link to each other through some difference, all right? And then from within each, we can say this connecting to this. Hold on. Let me think carefully. So with this, we can group words together. Like in this case, I have 0, 1, 2, 3, 4, 5, right? So hot and dot. So 0 and 1 are together. And with 0, 1, 2, 3, 3 together. Right? Hot and lot is together. And then dot and dog is together. So that's 1 and 2 are together. And dot and a lot. But that it's already considered. Hot dot lot. They are all considered. Now what we go through everything by once. Yeah, you know what? Let me just put it out and see how it goes. So we have this this T, and then this H O this, right? So this one we have 0. Everything we have is 0. Next dot we have star OT, D star T. We have D star T and DO start. Okay, and then dog. Dog is star OG, right? Star OG, and then D star G. We don't have D star G, so D star G and DO star, but we have DO star. Lot LO star. No, star OT. Star OT, okay? So 0, 1, 2, 3. Star OT. Star OT. L star T. We don't have L star, so L star T. And then LO star. We don't have LO star, so LO star. Okay, now it's star OG. We have star OG. That's 4. L star G. L star, don't have L star G. L star G is 4, right? And LO star, we have LO star. So next one, star OG. We have star OG. C star G. We don't have C star G. And then C star G. CO star. CO star. CO star. We don't have CO star. CO star. Okay. So once, now that I created all this, right? And all the ones that only has by themselves, so these we do not have to consider. These are not going to consider. So we only need to consider the ones that with multiple. So with multiple, it just means they have connection, right? So we can this is actually already. I think this is already a. No, this is not a list though. So we need to convert this into a. Holy guacamole! We need to convert this into an adjacency list. I mean, what we can do is every time we find a new one coming in, we just go through this and then just add it. Yeah, so for every one, add it to it. For every one, we add it to it. And for this, add those, add those. So we build a 5,000 in length. We build a, yeah, let's try this. I'm not 100% sure, but it could work. Okay, let's see. So adjacency list is going to be, I don't know, so it's going to be do you want index or do you want, I can do index. We can do index. I see the index has, if not index, we just push the actual word into it. A benefit of doing this is to avoid, because if I do index, let's do index. Let's do index. It'll be easier. But this one will still be. Can do dictionary, or let's do. Just do a dictionary. Okay, adjacency list is a dictionary, and then we gonna have group, right? Group is a dictionary as well, and then contain and word is equal to false, and then we just say for W in word list, right? For word in word list, and we simply say list equals list W, and for I in range len W list, return each I. So first of all, we're going to say if W is equal to n word, then contain n word equals true, right? And then we are going to look for it. So we're going to say W list I is equal to, let's say, a star, right? And then group key will equal to this dot join W list, and then this actually can be a default dict. That both can be default dict. Let's use default dict. Collection import default dict. Let's say adjacency list will be a default dict of list. This will be default dict of both of the default dicts of list, right? So we have a group key, and then we say for index in group, right? Group key. I'll just call it key. Okay. For every one of them, we say adjacency list index dot append I, and then adjacency list I dot append index, right? So I handle all this. Everybody's connecting to everybody else. And then I say group key dot append append I, right? Once we're done, double list I, go back to the original. Oh, we need a temp. So temp equals this, right? And then at the end, let's go back to temp. And now we find the 10 of them, right? Everyone. So blah 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 blah. And once we're done, then we say if not contain this, return 0. Okay. Now we're gonna go BFS to find the minimum length, which is result shall be equal to. Okay, result shall be. Oh, holy guacamole! We forgot to do one thing. We need to do the begin word. What is the index of the begin word? Why is the begin word index -1? Holy guacamole. I see the problem with this. You know what? That's not wise. Yeah, let's not use index. I don't like index now. For word, nope. Let's just say, this is fine. This is fine. Key is fine. And oh, this is not even I. I is the. Nah, this is completely wrong. But it's fine. It's not index for a previous word, right? pre-w, let's call it pre-w in this, and adjacency list pre-w dot append w, and adjacency w dot append pre-w, and this append w, and this, yeah, and then once we're done, we can simply say if and word, right, not in it's the adjacency list, right? So I was trying to say if it's not an adjacency list, because even if the N word is in it, but nobody's connecting to it, then that's not going to work. So it must connect to something, right? So if it's not in adjacency list, then we just return 0, right? Now BFS, but we need to find the starting, right? The starting. How do I find the start? I just do it one more time, right? So for one thing, we don't need this. And then we say if begin word not, if and not in adjacency list, begin word is not in, then we try to do it, right? Yeah, I want to add begin word into word list. You know, if I add it to it, if I add to it and then turn this into a set, yeah, maybe this is fine, right? We can just say it's going to be a set. Yeah, let's turn this into a set plus begin word. Right? We just add begin word into it. Now begin word is inside. Then we can say if end word is not in adjacency list, or begin word not in adjacency list, then just return 0, which means neither of them can lead out to anything. And in this, we guarantee that okay. Now we can BFS, right? Now we can say res equals 0, and then q is equal to, I don't know, begin word. And then how do you count? So this is 1, 2, 3, 5 word long. So the beginning shall be 1. Okay? And then we say while q, right, temp is this for w in q. If w is equal to end word, return res plus 1, right? Otherwise, we say temp dot extend, but we don't want to go back on, so we need to have scene. Right, scene is going to be a set begin word, right? And then we say if for neighbor in adjacency list w, if neighbor not in scene, right? If neighbor not in scene, then we say temp dot append neighbor, and and what? And scene.add neighbor, right? So we do this for W for each one in the queue. We do blah 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 blah. Once we're done, queue equals temp and res plus equal 1. Is that right? Yeah, because I'm in the first level, and then I try to find the second level, and then my level is this, and then, yeah. And then if nothing, then return 0. Okay. I am ready for testing. The test case is very straightforward. We have hit cog in this. The answer is 5. Second one I have hit. Same thing, but the answer is 0. Okay. This is picking word and word and a word list. A ladder. Picking word and word list. Run it. Name scene. Ooh, that is bad. Okay. What happened? Shall I return res? Now I start with 1, right? And that's the first level. And if this, oh yeah, it should be return res. Because res is already 1. I started 1, right? And then I check. And then, and then I go next one, we check the next one. So I just return res. Alright, let's try this. Yeah. Worst case scenario, just timeout. So I don't worry too much. I don't worry too much. Alright, let's see. Yeah, that's it. So it is the same idea, I'm pretty sure. Yeah, I've done this many times. You know the trick. That's 127. I've done this one at least 2 times in the past. And I have vivid memory of how it is solved. Now, there are 2 obstacles, right? First, we need to figure out a way to quickly find connections among words. Second, we need to build a graph of all the words and run BFS or DFS to find the shortest path from beginning word to end word if both exist in the graph. The graph traversal part of this problem is not difficult. The challenge is to find a fast method to build the graph. Now, I remember that we can replace each letter in the word with a star, and if two words if two words are identical after one letter, after the letter of the same space, after the letter at the same position is removed, they must differ by at most one. They must differ by one letter and thus have a connection. So W, so that's the length of the word on times length of the word. Yeah, so I think this is on, I'd say onk, and this is o in the graph, most on. So I think it's onk plus n, right? Where n equals len word list and k equals word list length of each word. Tired. 128. 89% rank. That's pretty good. Alright, let's just inspect the method I used in the past. I don't have to go through the discussion because I went through this already. Just kind of take a look. Oh. M squared. I was doing deck here. Intermediate state to word. Word to intermediate. Intermediate. That's the same idea that we have, but I think this might be better. And intermediate to word, word to intermediate. And VFS, speaking word. And then for intermediate, for each intermediate, and the final word. I see. I see what it is doing. So instead of building an adjacency list, it builds something else. It builds a intermediate to word and a word to intermediate, which is fine. I think the only thing that's better here, I think they use this. I like it. I like this better than the way I was doing it. Which means we don't have to do this. We can directly compute the key by doing string manipulation, which is easy, and I don't have to do this. Alright, so key is just going to be W, this, plus star, plus WI to the end. And of group key. So the group key, this is just the intermediate and a word, which is fine. And then, yeah, this is BFS is fine. That's just W. Ooh, what the hell happened? Huh. Shouldn't be from 1, so you want to replace it, right? Because it has to be 1 to replace the first and the last one shall be n-1. No, the last one, yeah, the last one is n-1. So I think it should be 1 to this. Hold on. If we go 0, right, so that's nothing. Oh, my bad. I plus 1. There we go. Yeah, but overall it's the same. Nothing to see. Was all right. Okay, so we have time. Let's do another one. Longest palindromic subsequence. Given a string S, find the longest palindromic subsequence. Subsequence. So it could be anything. Longest palindromic subsequence length in S. Okay. 2 1,000. Oof. Strain. My favorite. How do you handle subsequence? Like subarray, really, first ideal is sliding window, right? Subsequence is different. Palindromic. So if I have, say, a certain length, dp, right? So I have a certain length, I already find the longest palindromic subsequence. I already know it. Well, not only do I have to know the length, I have to know the actual subsequence. And then I'm encountering a new one. And do I have to list all possible? No. And that's not a subsequence, right? No, that's... we can now have a... Okay, so if I encounter a new letter and yeah, that's just... so I would find the longest subsequence, palindromic subsequence ending at each position, okay? So ending at each position, I can find the longest if I say the longest that involving me. Yeah, it doesn't make any sense. Anyway, so because it's palindromic, right? So if I find a B, to make a palindrome, we need to find the previous B, right? So if I have all the indices of the B, and I find a new B, I can look prior. Right, I'll look prior. If I look prior, I just need to know the longest, like between these two, right? The longest palindromic subsequence between these two, in between. Which means I need to find the longest subsequence at any given range, right? If I can find at any given range, then I find a new one. I do this, find one, this, find one, this, find one. Then I can solve it. Okay, so I want an all range, which means if I'm here and then I'm looking at the second one, right? If I'm at 0, or just by myself, the longest length at 0 to 0 is 1, and so 0, 1. Well, 1, 1 is 1, right? 1, 1 is 1, and I need to find if and then in between. What if there's nothing in between? If there's nothing in between, then that's just a 0. And so find something previous if there is. If there is not, then that's just by itself, right? Which means from 0 to 1 is just going to be hold on. So I'm at 1, right? Assuming like everything in between is all found. So I just go to the front, but in the middle is not being found yet. That's the issue. That's the problem. That is the problem. It's not being found yet. Right? It's not being found yet. If I go step by step, because if I go step by step, I will say 0, 0, 1, 1, and then we go 0, 1, 1, 2, and then 0, 3, 2, 3. Is that the right way to go? And then 0, 4, 2, 4, 0, 4, 1, 5, like that. Because I need everything in between to be identified first. Okay, so I can loop through everything, find everybody's index first, and then I build this DP. Right, it's going to be a 2D array, and then I'm going to go size of 1, size of 2, size of 3, all the way to and every time. Yeah, let's try this. This is gonna be like I think it's a bottom-up idea, but maybe if we can do it top-down. I like to do it top-down. So given this, right? So when you call the function, you call this whole thing. But when I call the whole thing, I cannot solve. So I'll call whole range, right? It's the whole range from this to this is the whole range. So what I will do is I will look at the end value, right? And then we go through everything that is bigger than this, bigger or equal to this. Find all of them. Every time I find them, we recursive call this. Recursive. Yeah, let me first write the top down. I like to write top down first. To me, top down represents the logic, the pure logic. And I think top down usually is also faster because it's the stack and everything is handled. So we do need a default dict. So from collections import default dict, I need to know positions. List, right? And for I, a letter in numerate S, I need to know each one's position, okay? And then dfs, not dfs, I just called helper. We're gonna have low, how about low and high? What does this return? This is return int, the longest, right, subsequence, and palindromic subsequence. And then what I do, we say if low is equal to high, we always return 1, right? Otherwise we're gonna say for, we look at high, right? So we say for I don't know, for I in position high, okay? For I in position high, no, position S high, right? And we say if I is smaller than low, continue. If I is larger than high, break. Otherwise, it's in between. It's in between, right? So it's in between, then we'll grab that, and then we have the rest is equal to 0, right? And then we want to find the maximum longest. So we say rest shall equal to maximum rest, and I call helper. Helper what? Because helper will be down, will be I plus 1, that's the low, because I is in here, and the high will be the high minus 1, right? And high minus 1. So in here, I just need to try to find this range. Right? Let me think. Uh-huh. Okay. Okay. But do I have to call this function? I can't just call low to high, right? Because if I call low to high, what I want to find is within this range. And I pick this, and I find everything that's equal to, then I've done everything, right? But the starting position is always low. Hold on. I feel like I'm getting close. I'm getting close, but there is there is something missing. How do I call this function? I can just call low to high, right? If I call low to high, I will be missing a lot of stuff. Because this I'm just considering the end position as high, right? And I need to consider the end position as all the others. Like this. Every end position I need to consider. Okay. So res helper is I plus 1 because I is the same. So I plus 1 to this. And I'll do whatever it needs to do. And it's going to return res. So what I want to have is have a res here that's 0 as well. And then we say for I in range len s, right? Res equals max res helper. A low is just going to be 0, high is going to be I. And then we'll return res. What do you think? Oh, I have to functool port cache. With functools, right? I'm not 100% sure. Let's try. Have this shall equal to 4. Maybe it's functool, not functools. This is C BBD shall be 2. S longest S. That's functools. Alright, the result is not right. Interesting, huh? So we're going 0, 0, that's going to be 1. Then we go 0, 1. Oh, should we helper this plus 2? And if this is, if low is smaller than high, return 0. What? That's still in right. Okay, so 0, 0, and 1. Now we're going to try 0, 1, right? 0, 1. 0, 1 coming in. Now it's a little larger than high. There we go. Let's try this. We can supply a few test cases. Let's see. For instance, A, right? And free estate, right? One extremely small, one extremely large. Nah. See that? See that? We have the issue. 14. Expect a 21. Okay, so let's simplify this. See if we can figure out where the problem is. Keep half. Most likely, just like there are some cases where we didn't find. I want to know. This one's correct. Okay, this might be good enough. 1, 2, 2, 3. Wait, what was the result? Expected 3. I got 4. That's slightly different from what I had expected. I got 4. How did I get 4? High minus 1, low plus 1, right? So this is in between. I have the longest, and then we have added 2, right? And if in the middle is going to be 1, hold up. So we're looking at from low to high, right? And if the high it doesn't have anything, then we shall return. So I think shouldn't the rest be 1? I'm not sure. I'm not sure if that's doesn't feel to be the case. Yeah, we still return 4. All right, so I need to make some help. Oh, yeah, this one. All right, so the answer shall be 3, but I got 4. That's fine. Let's take a look. All right, so let's print I and helper 0i. Okay. I is 0, got 1. That's 2. This is not right. This is not right. I am at S, right? So 0, 2. I'm at S, and rest is 1. And for I in position is high. There's nothing. You should return 1. Okay. This is interesting. Hold up. Hold up. Print position GS is 1, yeah. Oh, equal. If I or I is equal to high. Yep. So I'm going to skip the value that's currently being considered. Okay. Really. Okay. All right. I'm gonna do same thing. Wow. This is terrible. This is terrible. Expect 45. What I think is some is not considered. That's my fear. So I'm going to consider every range, right? I'm going to consider every range. which means we're going to say for L in range 1 to len s plus 1. This is the length. And then we're going to go for I in range from the start to len s minus L, right? This L can be len s, and this I in range, that is going to be 0. No. I has to be taken as 0. Hold on. This has to plus 1. Alright? I is 1. Yeah, it has to plus 1. And then for every single thing, because we cached, so it doesn't really matter, then we simply do this. Alright. Right, so my helper is going to be I, is the starting, and then the end is I plus L. So if it's going to be minus 1, right? So if L is 1, so hopefully this can handle every case. Okay, tried it. Oh, this is still not right. I'm going through every single range, right? I'm going through every single range. How is this not correct? For I in position. Are you correct for these two? Oh, it's not correct for the first one. What happened? Alright, again, helper. We're trying to find from low to high, right? If low and high is the same, that's going to turn 1. If low is larger than high, that's going to turn 0. This all makes sense. Result is 1, because with this one, we're focusing on high. Right? We're focusing on high. We're trying to say, if I add high, can we form? Okay. So if high needs to be at the end, then we say we go through the position, and if it is smaller than low, I don't do it. If it's equal to high, I think you say larger equal to high, and we break. Hold on, I can be high. If I is high, okay, then I say, like, if I don't find anything, like if I don't have anything, then I simply say, okay, I'm just going to return 1, right? Oh, it's not 1. It's not. It's not. Yep. I think I know what happened. This is not right. Yep. This is stupid. Okay. No. This is not right. This is not right. So result is this, right? And this is, we say, we have to find this. And then, because I want to find this, so within this, all right, using this, I can now go, which means it cannot end at this position. So it has to, and let's just shrink it down to this, like among this, what is the largest? Because within this, the largest is 1. I shouldn't say is 1. It's within this range. If I'm looking at my end position, we say it has to include the end, and it doesn't work. Now I say I have to include this, right? So anything has to include this, has to include this, has to include. So anything, if we can form, then it shall be able to form. So we shrink down from the right to the middle, to the front, which means this is fine. Then we shall say in here for from right to the left. Consider every single one. For I in range, yeah, we can go from low to high, right? We have this range. Or sorry, find see if this one has anything in here, right? If this one has anything in here, or this one. If nothing, then we go here, right? And then if nothing, then we go here, until if none of them have anything, then eventually we'll get to 1. Yeah, which I think I actually say from low to high, right? And for each one, we can say for j in position si, right? And then for j in position si, then we say if j is smaller than, so it's the same thing, right? So say if j is smaller than low, we continue. If j is larger than high, we break. Otherwise, rest equals this, and then we do. So we find a j, right? We find a j, and then we have an I. Now it's not large, it's larger than I, then we break. No. No, it's larger than high, but it's smaller than I, not low. Because I is from low to high, right? I'm gonna check every single one, and so for every one, we go to the positions. I go to the positions. It's SI. We go to the positions. So everything smaller than I don't consider. So I will be the first one I consider, right? I'm the first one I consider, and I say an helper is going to be I plus 1 and high minus 1. Right. I plus 1 and high minus 1. So we're looking at, it's actually not I, it's j, right? We're looking at j from I to j, right? So it's from I to j. So we can actually avoid doing this. So from I to j, we say if I is equal to j, then we don't have the call. And if I and j is different by just 1, I don't have the call. If it's a lot bit larger than 1, then I call, okay? Because I and j, anyway, we'll have 1 that's the same. So we don't need this, right? But we do need, we say if I is equal to j, res equals max temp equal to 1 out of I, because j is I plus 1 equal to j, because I still cannot do this, right? If I plus 1 equal to j, that temp equals 2. Right, temp equal to 2. Else temp equals helper. Now I can do helper I plus 1. High, no, j minus 1. And this one can plus 2. And we do temp. And in here, we simply return helper 0 to len s minus 1. Shoot, that's still not right. What the hell? What the hell is happening? That goes from 0 to high, okay? So I'll go inside. They're not the same. And then rest is 0. And I gonna go from low to high. I'm gonna handle every single one. So for each I, j is gonna be position si, so position here, right? So the first one is I equal to j. Okay, so rest equal to 1. And then go back up. J pointing to here. Now that's I plus 1 equal to j. So temp equals 2. So now rest equal to 2. Come up from here. And this is, none of these matter. So we're going to do I plus 1 and j minus 1. So that's why I'll give it 1 plus 2, that's 3. So now equals to 3. Right? And then it will go, the last one's here. Right, last one's here. So I is here, j is here. So we're going to go I plus 1 and j minus 1. So we're trying to find the total number within here. Okay, so now this is our recursion function in here. And then I have here this, right? and then this is high, this is I now, and j in this is small, so I skip. The next one is this is the same, so this one will return 1. The next one is this, shall return 2. And then that's it. Next one, this one's larger than. So we don't also have 2, right? And then I'm moving forward. Again, checking. Smaller. Only, maybe, what's the length? 1000. This is giving 1, but it shouldn't be updating, right? And then last one is here. That's also 1. So it should return 2. That shall return 4. Hey, why does it not return? Interesting. Let's see. Print I, j, and temp. Okay. 0 is 1. 0, 1 is 1. 0, 1, 2. 0, 2 is 3. 0, 1 is 1. How is 0, 1 is 1? Oh my goodness. That was a typo. Didn't expect a typo. There we go. Now I think we're good. Yeah, I'm just not sure. Try this test case. Yep. Alright, let's go. If it does not time out, if it times out, I'm going to use binary search. Madre mia. Holy guacamole. It times out. Okay, then we have to do binary search. Yeah, I'm just gonna try binary search just to try a little bit. Right, just try a little bit. And of course, I'm using here because this is my current is I, right? So I'm gonna say index equal to bisect right, position si, and then a I, right? Because I is always in it, so the index will be, to the right. So what we're gonna do is for, wait, hold up. This one will find, oh, we can actually, hold up. We can narrow it down, right? So index, I'm gonna say low, right? Index low and index high. Index I, right? And index high, bisect right, position si, and I'm gonna search for high, right? Because these are the two things we were worried about. And then we just go through in between. How to go through in between? We're gonna say for k, right? In range from index I, well, -1, because we can take that, and all the way to index high. And index high we cannot take because that's high, right? We'll insert to the right. So this one we don't take, but we can take the one in front of it, which is fine. So I'm gonna do this, and then we don't have to do any of this. And we say j equals position, position SIK, and everything else is the same. Okay, so let's try this one. See how it works. This one times out. All right, let's try this. See how fast we go. Ay, 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 ay. Binary search is still no good. Ooh. You know what? I'll just call it a day. I'll come back to this tomorrow. I'll give myself a night to think it over. Binary search still doesn't work. But if you think about it, of course it doesn't work because this is O(n) squared. We're doing 1,000 times 1,000. Wait, 1,000 times 1,000 is too much? I have some new ideas.